Hello everyone. In today's video, we will be discussing the working of MergeSort. First of all, before starting with MergeSort, it works on divide and conquer methodology. Now, what do we mean by divide and conquer method? In this, a main problem, so there is a larger problem which gets divided into smaller sub-problems, and this is the divide step where we are dividing a larger problem into smaller ones. Conquering is to solve these smaller sub-problems, and after we have the solution to these smaller sub-problems, all these solutions are combined to form the solution of the larger problem. So instead of solving this bigger task at hand at once, we are dividing it into smaller parts. Those smaller parts are solved and all those solutions are combined to give the solution to the actual problem in hand. Okay, so considering this divide and conquer strategy, MergeSort algorithm works. So basically this is a sorting technique. Sorting is to arrange the given numbers or alphabets in a sorted manner in an ascending order. So here it is based on divide and conquer technique. Okay, so we are here going to divide the task of sorting into smaller parts, sort the smaller parts, and then keep on combining their results to get the final sorted array. Okay, so what is the first step? It divides the array into equal halves. So as we have studied in binary search, we find the mid and look either in the left or the right of the array for searching the elements. Similarly, in MergeSort also we find the mid of the array, and then this part of the array and this part of the array get sorted. But this is not only dividing once into half the array size, it is repeated until we get the elements of dimension 1 or a single element. So this is divided until we get single elements. So that is called as dividing the array into equal halves. And then what is done, we combine these individual arrays, and that is done in a sorted manner. So first we are dividing and then we are combining in a sorted manner. So this is how MergeSort works. So let us see these things in detail. So since we are using this divide and conquer technique, we need to know what is our larger problem and what will be our sub problems that we will be designing. So what is the entire problem for us? Since it is a sorting algorithm, we intend to sort whatever is the input array. So it may be a large input array and we wish to sort the elements in this array. So this is our entire task at hand. And what will be the sub problem? We will be dividing this entire array into smaller arrays or sub arrays, and sorting them will be my sub problem. So after we have smaller sub-arrays sorted, we have to combine them to give the result for this entire array. Okay, so let us assume here that these indexes from P to R denote the sub-arrays, and the original array or the original problem is to sort the array of size 0 to n minus 1. So if we say that the array is of size n, then there will be elements or indexes going from 0 to n minus 1, and this is the original array. And then we will be dividing this entire array into smaller sub-arrays, and let us call the sub-arrays getting denoted by indexes P and R. Okay, and using these notations we will be discussing the MergeSort technique. Okay, so we already know that we need to divide it first, then we will be solving or conquering the subproblem and then combining the results. So these are the major three steps. Okay, so how is it done? So we need to first of all find Q, which is the position of the midway between the indexes P and R. So that is for every array or sub array, we are going to divide it into two parts by finding out the mid position. Again, this is also found using the technique which we have discussed in binary search. So what is done, if we have P and R being the indexes of the array, so for example this is my array and the indexes here range from say 0, 1, 2, 3, 4 and 5. Okay, so what are we expected to do? This P and R are nothing but the indexes of this array. We will be uh, adding the indexes and dividing it by 2. So add these indexes, divide them by 2 and round down. Okay, so this is 0 plus 5 by 2. So here it is rounded down. So we get 2 as the midpoint. So here we will be dividing at this position. Okay, next is to conquer, that is recursively we are applying the sorting algorithm to the sub arrays and we are sorting them. Okay, so the first sub array, as we are dividing it with a mid position called as Q, so first sub array goes from 0 to Q and the next array is Q plus 1 going till R. Okay, since the entire array was going from this P to, yeah, so this is P. So it goes from P to R. So this is P to Q and then Q plus 1 to the last element. Okay, so for all these arrays, we are recursively going to apply the sorting algorithm and sort. Okay. And then combining is merging these two sorted sub arrays back into a single array. So again, after you have sorted this part and the other part, you will be combining it again to get the entire array of which goes from P to R. So this is the entire logic of dividing, conquering, that is solving the smaller subproblem, and then combining to get the final result. So let us take an example here. For example, we have an array going from 0, 1, 2, 3, 4, 5, 6 and 7. So there are 7 elements in this. So there are basically n is 8 or 8 elements are there in this array, which range or the indexes in this array will go from 0 to 7. Right? 8 elements going from 0 to 7. So what is P? P is the first index element, that is 0, and R is the last index element, that is 7. Now we have to divide this into smaller sub arrays. So we have to find the value of Q. So Q is P plus R by 2. So this is 0 plus 7 by 2. So this will be 3.5, but we have to lower it to the, we have to round it to the lower number. So this is 3. So value of Q or the mid index is 3. So what is done? At this index 3, you are going to break the array. So if you see here, we say go from P, include the Q element in the first sub array itself. So what we do is we know that this is the breakpoint, and so we know that this is my breakpoint. So you have to create two sub arrays. One goes from 0 to, or rather P to Q, and the other goes from Q plus 1 to R. So this goes from 0 to 3. and the next goes from 4 till the end. Okay, so now we have divided this entire array of 8 elements into two parts. Okay, so now each array has 4 elements each. Although we don't stop here in MergeSort, but let us see by some uh, method we are dividing it further, and later on in the conquer step we will be sorting these sub arrays. So this sub array 1 is sorted by applying a sorting algorithm. So this becomes 3, 7, 12, 14, and then this second sub array is also sorted. So we have two sorted sub arrays, and finally these two are merged or combined into a final sorted array. So again, if you see here, whenever we are merging or combining the two different sub arrays, we are again applying the sorting algorithm so that the final result is also sorted. Okay, so this is the idea behind dividing and conquering. Now we'll see exactly the solution to merge sort, what is done if there is a larger array given, and how is it divided into sub arrays until we get the arrays of size 1. That is, every array should contain element of size 1, and after that we keep on combining them by applying the sort algorithm. So it is merging as well as sorting. So it is done recursively here. So if we say the same function of dividing is applied again and again, and for merging also we are sort and merge is applied together. So since we are doing the same function again and again, we can call the same function or call itself in a recursive manner. So the problem or the program which we can write will be based on recursion. Okay. Yeah. So let us take an example here. So if you see, this is the given array of 8 elements again. So we have size of this array as 8 because we have 8 number of elements which can be present in this array. Here we represent the indexes which go from 0 to 7. The first index is called as P, last index is called as R. Here are the array elements, and how do you find Q, which is the midway for both these given indexes start and end? So this is P plus R by 2 and rounded to the lower number. So this is again 0 plus 7 by 2. This should be 3.5, but we are rounding it to a lower number. So we get Q at index number 3. So where do we have to break this? At this. So we have now an array divided from 0 to 3 as the first sub array, and the next is divided here from 4 to 7. Okay, so now we have this as the sub array 1 and this has the sub array 2. Now this becomes the original array, which is again divided into two parts here. So now this becomes P, this becomes R, and the value of Q will be 1. So we break it here, giving us two arrays again. Okay, so this division is going on continuously. So we are applying this division function of finding Q again and again. So that can go in recursion. So this is again divided into 14, 7, 3, 12. So we do not stop here. We continue until we get the array of size 1. So this is P, this is R, Q will be 0 plus 1 by 2. So here we get 0. So since it is 0.5, so we'll be rounding it to 0. So this is our Q value. So we know that this is the breakpoint. So we divide it into two parts again. So we get 14 and 7 divided here. So now we have the array of size 1. So similarly, this procedure would be applied to all the sub arrays. So this 312, this is the 312 which also gets divided into two parts. So we have single elements coming here. So as the procedure is applied to this left subarray, it is also applied to this right subarray. Okay, so in this again it will give me Q value as 5 here, and it will be broken down into two parts. Again we have two arrays, again break it down and we get arrays of size 1. Now till here we are in the divide step, wherein we continuously divide the array until we get the arrays of size 1. So this is what MergeSort does. It divides the arrays into sub arrays until we get the arrays of size 1. Okay, and then it starts performing the merge operation by merging two arrays. Okay, so now it takes these two arrays. While merging, it is also performing the sort operation. So now when you merge these two, you see that the 7 or this value 7 is smaller than 14. So 7 will be the first element and then 14 becomes the next element. Again merge these two elements here. 3 is smaller than 12. So these two elements. Again merging and sorting. So 9 and 11. Merging and sorting. So we get 2 and 6 here. Again in the next stage it will merge two arrays or two sub arrays. So again this will be sorted. So 3 is the smallest number. Next is 7. Next is 12 and next is 14. So this is this is the array after merging as well as sorting. Similarly here also we will be merging and sorting, and then finally last array will be obtained by merging and sorting the elements. Okay, I hope this is clear to everyone. However, we will discuss one more problem so that it is more clear to everyone. So this is we have discussed. If you wish, just you can read through this. We have discussed it here while solving. Yeah, so let us take one more example here, and I'll give you a small set of array. So these are the array elements which are given to us, and we are expected to sort this array using the merge sort algorithm. Okay, so these are the array elements, and here we have the indexes. So we call the first index as 0 or P, and then we give the index numbers here. So if you see here we have 8 elements again going from 0 to 7. Okay, so once we break this again we will find the value. So this is R, sorry. We will find the value of Q, which is 0 plus 7 by 2, so we get 3. So at the first step we are breaking it here and we get two sub arrays. And here the sub arrays range from 0 to 3, and the next is broken into 90, 27, 72, 18. Here the indexes are looking as 4, 5, 6, 7, but you can assume them to be 0, 1, 2, 3 since we are again recursively calling this function. And since this is another array which is created, you can assume it to have the indexes. So in practicality when this is going, so this is 0, 1, 2 and 3 only. Okay, however considering the indexes which are shown here, so for representation we say that it is going from 5 to 7, but no array can start from 4 as the index, it starts from 0. Okay, so now again we will recursively divide these sub arrays also. So P is 0 and R is 3, and if you divide 0 plus 3 by 2, So here we'll get 1.5 and we break it here. So we have 39 and 9 elements here, 81 and 45 coming here. Similarly, this is 0 plus 3 by 2. So again 2 elements in the first array and the next 2 elements in the next sub array. So this is 0, 1. Again these are also 0 ones. So 0 plus 1 by 2, it gives me 0, and you break it down. So you get individual arrays of size 1. So here also when you break, we get individual arrays of size 1. Similarly, all these sub arrays are broken down until we get the array of size 1. And now after this, so till here we are done with the division of the sub arrays in, or division of the given array into sub arrays. And now we will be starting with combining and solving these. So two sub arrays are combined at once. So when you are combining the elements, they are getting sorted. So 9 is less than 39. So 9 will be the first element and then comes 39. Again, when you combine these two, 45 will be the first element and then 81. Then we are combining these two, we get 27 and 90. Combine these two, we get 18 and 72. Again, two arrays are combined. So we are combining two sub arrays at a time. So these two will be combined and these two will be combined. And while combining, you have to sort. So you take one element, this is the smallest, next smallest element, next smallest element, and so on. So here we have 18 as the smallest element, next 27, next 72, and 90. And then finally these two sub arrays are also combined into the final array. So we get 9, 18, next is 27, 39, 45, 72, 81, and 90. So this is the final sorted array that we get, whereas this was the input. So we divided it into smaller parts, sorting, dividing, and then combining to get the sorted arrays. Okay, so this is called as divide and conquer technique to solve to get a sorted array. So this is the functioning of the merge sort. Yeah, so this is a very good algorithm if you try to work with the data structure called as linked list, because that does not require any additional spaces. You just have to manipulate the pointers. However, if you do not use linked list, then this algorithm may not be very efficient. Why? Because you are dividing the main array into sub arrays, and these sub arrays are also occupying memory in the system, right? So it is not preferred for sorting data in the main memory, and it uses, since it creates the copy of the original arrays by having two sub arrays. So there is an additional work of creating a copy first of all, and then it requires more amount of memory since you are creating the additional copy. Okay, however, this algorithm works. So the best case and the average case complexity is n log n. So this indicates that what is the time required for execution. So n is the number of elements. So this is n log n is the time even in the worst case. However, an additional space of on is required. That is, since every time you are creating a copy, you will require additional space for the working of this algorithm, and that is the drawback. Otherwise, since you are dividing it into smaller parts and doing the execution, So the execution time is good, but space requirement is large. So for that, if you use linked list as the data structure, then it will be giving you a good result, because in linked list you're just manipulating the pointers rather than creating the copies. Okay, so this was all about merge sort. Thank you and happy learning.